The second way is to compile everything completely from scratch. Let's take a closer look at this process. Since this usually takes quite a long time, I do not plan to run the entire process all the way through right now, but instead I will just post the command here for you to see. First, for our specific card, we can go ahead and restart it to make sure everything is set up properly before we begin. Give it a restart. Okay, your project is still there, and that is because after the restart, your project is still safely stored in this storage area. So we can just reconnect to it directly. Of course, when you try it, try to keep it clean, because right now it's already able to support our second demonstration. Then 2256, 2256, 133, okay. Then we reconnect, its port hasn't changed. Alright, let me take care of that for you right away. Let's step into our own space together. This is a bit more troublesome because it might consider your actual environment, your real surroundings in this case. For example, now that we're in, we can create an environment. We ensure its environment is isolated, so we create a new one. Then at this particular point in the process, what we need to do is check, for example, if there is at this moment a torch version available now. It doesn't have one, so now we need to start running this command. For example, for my demo, I'll use 2.9 first. This depends on the specific situation, because when you're solving different issues or tasks, you need to consider the user's setup. First, what card they're using, and second, what the vLLM version is and what the PyTorch version is. You must check these clearly. Also, sometimes you need to check the corresponding CUDA version and those driver versions. But if you want to compile our vLLM, you'll definitely need to download Torch after you get in. You need to decide how large a version to download. Like which version is 12 point, like mine, which uses this Torch. Torch 2.9 actually has pre-downloaded packages inside the installation. These are downloaded directly from PyTorch, so we actually need to look at it on a case-by-case basis. Compiling everything from scratch will definitely take quite a long time, mainly because vLLM needs to download a lot of dependencies, including things like CUDA and ROCm, onto your current machine. So just be aware that this process can take a while. Generally speaking, unless a user has specific version requirements, we recommend the first method. When I spoke with some community maintainers, they also mentioned that they used the first method for their daily model development and for fixing common bugs. This approach is quite common. Now, let's take a look and verify this together. Torch. Okay, 2.9 plus CUDA is 129, so when we want to execute this, we definitely can't just run it directly. That simply will not work as expected. Since there are so many different tasks in vLLM, we really need to set a proper limit. If you have an A100 or H100, you can set it to 32 or even 64, depending on your needs. But for our maximum job count, let's set it to 16, since our card is actually too small and probably might not be able to handle more than that. If you don't set this number and just compile, it will eventually crash. It'll just run out of memory. So remember, you must include this. So we need to run this command. Okay, this error is actually due to some missing packages. As you saw, we need to download them, so I will post the commands you need to run in the correct order a bit later. Please do not panic when you see an error like this. Just calmly install the necessary packages based on the situation. This is simply a missing package. Now let's go ahead and add this one as well. Okay, now let's just take a moment and try running that particular command again, just to be sure. this is where people often tend to run into errors. It's not only about missing dependencies, there are also mismatches that can happen with flash attention. This actually involves hardware levels, like with the 4090 graphics cards. And then he uses that, flash attention too. And then there are many scenarios like this. So we need to, look at it based on the situation, especially this compilation step, because once this is compiled, then we can see what follows is it's several hours, which is a duration of several hours, until finally its output is success build vLLM. So this successful build vLLM, this means it's succeeded. This is just like our pre-compilation environment. Now that error I just had, it actually, it came from a conflict in here, like something wasn't found. So I just stopped using that format. I just directly first this no build isolation. And then I switched to just using this alone, this pure compilation format, to let it run. So actually now we'll see the output in here all the way to here. This is what we just saw. It will go to building, and then to construct, and then it starts to load all of its packages, and then later, further down in the output, you can also see the compilation of many operators. So this part is the very time-consuming part I mentioned right here. It might compile for a long time. And then we'll see this indicator keeps going up because its CPU, it's constantly going up to do all this compilation work. There's another situation where there's another error just as the compilation is almost finished. This kind of situation is also very frustrating. So this kind of situation will of course require you to take your current corresponding scenario, like what card you're using. What is your vLLM version? What is your PyTorch version? Is your flash attention version mismatched right now? And so on. These issues might cause an error just when it's almost successful. You need to record this and then analyze it based on the specific situation. So actually, if we're compiling from scratch, the common commands are these ones I'm using now, and then the rest is just you drinking a coffee and waiting for it to finish compiling, because it takes a long time. Maybe because when I compiled one back then to fix a bug, it was about a specific version I compiled from scratch, and it took 3 hours. It's second only to PyTorch, because with PyTorch, when I compiled PyTorch from scratch, it took me about 5 hours. Right, and we need to keep an eye on whether this part will eventually max out and cause an We need to watch for that, but with our card it shouldn't, because we set its maximum number of jobs to 16, so if 16 still errors out, then you change it to 8. It'll be slow, as the number of jobs corresponds to the compilation time. If the number of jobs is smaller, then the time will be longer, so I hope everyone pays attention to this. Okay, in this demonstration, I just want to mention that I won't be waiting for it to finish compiling, simply because it honestly takes too long. So you can go ahead and put your comments about the compilation situations you've encountered in the comment section of the video that I'll be posting. Once I see them, we can have a discussion based on the situation. Okay, thank you all very much, everyone.